Okay, so we're 1.3. It's our last day. We're going to finish up our rules. Theorem 1.4 just basically says when you have a radical, so I have the limit of the nth root of x. I'm just doing that straight substitution again. Plug in the constant and go. Okay? Rule 1.5, it's composition. See how we have f of g of x? See that? So it says if I find the limit of g of x, I just plug that into f. So you find the limit of the inside function and just plug whatever that is into f. You don't do the limit twice, you do it one time.
So what should we write for the first one?
I would just write the rules. Just write the rules. Hopefully you have them already written down almost.
We are not talking.
Okay, guys, good? Yep.
Sure.
Are you sure?
It's fine, I'll just do it later.
Well, where are you at? Are you almost done?
I have to start writing the limit on the bottom, so it's fine.
It'd take about 30 seconds.
So do we need g of x equals L and
You need that everything circled in red.
okay.
You should know that capital L means the limit.
Yeah.
So on the composite, you just do the limit of g of x and plug whatever value that is into the actual function of f. You only do the limit one time. Okay?
Was some of this already on our assignment?
I think no. I don't think so. Okay, I feel like we've skipped a slide. Did we do this one? Yes, we did this one, Riz.
Yes.
Okay. Okay, it says find the limit of the composite function. So we have the limit of f of g of x. So we need to do the limit as x approaches 0 of x squared plus 4. Because that's g of x. Yes? Okay, and what do you get?
Wait, wouldn't you 4?
You just plug in 0. So you get 4. Yes?
Where do the square root go?
We're not doing that because it's f of g of x. So we have to do g of x first.
Oh.
Okay, so we get 4. Now we have the limit as x approaches 4 of f of x. So we have to do now.
Square root of 4.
So we have the limit as x.
Oh.
No, sorry. We have the you're fine. Square root of 4, which is what?
2.
2. So you do one at a time.
Oh.
Okay, so the next one, there should be extra parentheses here. Okay, so the limit of g of x, the limit of f of g of x, should have switched those around. And we got f and g, right? So we're going to start with what? G?
Yep.
So the limit as x approaches 0 of the cube root of x, which is going to be what?
0.
0. So then we put the limit
Negative 10.
as x approaches 0 of 2x squared minus 10, which would be
Negative 10.
negative 10. Just inside out again. Could I do 16 of them if I wanted to?
Yes.
Questions?
Sorry. So you'll like treat them as like two separate.
Yep,
equations?
just like when we would do f, like if we did f of g of 3, I would put 3 in g, and then my answer I would put in f. The same thing, but my answer is the limit.
Okay.
Sadie?
So, okay, so the first one, the second part of the first one, where did x approaches 4 come from?
Okay.
Because this is g of x. This is the limit of g of x. And then we take that, and so replace the 0 with the 4 of f of x, which was the square root of x.
Okay. That's it.
Okay.
I'm just trying to think of how.
I feel like we should have a problem in here. Okay, there it is. Okay, now we have some rules. Please just look at them before you write them all down because, guys, all it is direct substitution. And I think my statement would be 1.6, limit of trigonometric function, direct substitution. I do not think I would write this all down. Do you see what's going on?
Yeah,
You just put it in. Don't, writing that whole mess down is going to make you think it's hard. Is it hard? No. When you have a trigonometric function, you just direct substitution. Got it? Okay, so it says find the limit. So the limit of the tangent of x as x approaches 0 is... I always
we
forget.
just write substituted in.
Yep. So it's tangent of 0. What is the tangent of 0?
0.
0. That's it. And you should know them that quick. Probably need to review them. But any quadrantals should we know pretty quickly. Yeah. Okay. So then I have the limit of x cosine of x as x approaches pi. So I plug in what? Pi. So pi cosine of pi. Well, what's the cosine of pi?
1. Pi. Well, -1.
Negative 1. So the answer is
pi.
negative pi. Just direct substitution, that's all I'm doing. Okay, so now I have the limit of sine squared of x as x approaches 0. So remember the squared is on the outside. What I really have here is the limit as x approaches 0 of, actually, sine of x all what? Squared. Like I do everything else then square it, right? So then I have the sine at 0 squared. Well, what's the sine at 0?
0.
0. And 0 squared is
0.
0. So all I did was direct substitution. Questions?
I lied. We actually already did this. And
That's what I thought we
the
did.
Next slide, we stopped at reducing on the next slide.
I thought we did.
And that's the, because, yeah, I already have all this written down.
Hey,
So we
did.
I asked.
I thought,
Okay, so here are the strategies. Please make a note. If I'm not going to sit here, if you want to copy all that down, make a note that this is in your textbook. Okay, this chart is directly from your textbook. We would be here forever if you wanted to write this all down, right? Okay, so the very, very first thing I should do is direct substitution. Yes.
Yep.
Yes. If that does not work, okay, you should think about if a limit of f of x approaches a c that is invalid, makes the denominator 0, I should simplify and then do direct substitution. That's what we did on the slide before that we did last week. Okay? If that doesn't work, you could apply theorem 1.7 that you could we could do the composite. Okay? Last, graph or table. Graph or table is not my first option. That is my what?
last.
Last. If I cannot verify it from any of these things I've told you before now, then you go to a graph or a table. Understand me? If all of those things came up with 0 in the denominator, or everything was telling me undefined and I couldn't say anything conclusive, then I need to make a graph or a table. Because just because it says undefined does not mean the limit doesn't exist, does it? So you can't jump to that conclusion. So again, this is all in your textbook, that chart. But basically the biggest thing is, what is the very last thing you should do?
Tables and graphs.
Last. Always last. Okay, what is the very first thing you should do? Just direct substitution. Direct substitution, and then if that doesn't work, you should simplify and use direct substitution. And then if that doesn't work, graph or a table. Okay, so we got to find the limit. So direct substitution. So if I would, in my brain, it's a fraction, yes? Now, I need to worry about a fraction, what being 0? Denominator. Well, -3 is going to make that what? 0.
They're both gonna be 0.
So, can I do this? No. Okay. If I plug in a -3, I get 9 minus 3 minus 6 over -3 plus 3. I get 0 over 0. That is called an indeterminate solution, meaning I can't determine what's going on. So I've also taught you, any time you see a rational function, should you always try to simplify first? Yes, that would be the best thing to do regardless. Okay, so I have factors of 6 that have a difference of 1. Just factoring. 3 and 2, and the 3 is going to be positive, right? So I get x plus 3 and x minus 2. You notice this is work, guys. This isn't an answer yet, is it?
No.
Over x plus 2. Oh, plus 3, sorry. Can I reduce anything?
Yes.
The x plus 3. And we're now down to the limit as x approaches -3 of x minus 2. These are equivalent statements because they both had the x plus 3 in there, correct? Now does it work?
Yes.
Yeah.
-5.
It's now -5. So what was this called? What kind of a solution? Indeterminate, because I can't determine anything by it. It's not undefined. It's not doesn't exist. It could be doesn't exist, couldn't it? But we have to go further to see. That didn't answer the question for me. Make sense? Okay, so now over here, if I plug 0 in, I get 1 minus 1 over 0, so I get 0 over 0 again. So I have an indeterminate solution, don't I? Okay, so if you remember right, the very first slide a long time ago, I talked about the conjugates, yes? Yes?
Yeah.
And I have a square root, and sometimes when I have square roots, I need to rationalize and move the square root. I can rationalize even from the numerator. So what would the conjugate of that numerator be?
Square root of x minus 1? No.
It'd be the square root of x plus 1 plus 1. Remember, it's the middle term that changes. And if I multiply the top by it, I have to multiply by the bottom. Because I really just multiplied by 1, didn't I? Because it's the same thing, top and bottom, I just multiplied by 1. So now, I'm not going to distribute the bottom because when I'm done, hopefully I can do direct substitution. Yes? Now, these two terms are difference of squares. So the middle term is going to reduce out. Yes? So that means I square the first, subtract the square of the second. Yes? So if I square the square root of x plus 1, I get what?
X plus 1.
I get x plus 1. When you square a square root, you get what's inside. Yes? When I square -1, I get what? Well, it'd be -1 times +1, I get -1, yes? All over x square root of x plus 1 plus 1.
Wait, where'd the other one on top go? We're not squaring that.
We did. We took this times this and this times this. When you do conjugate, that's the only thing that's left, because remember that inner on a conjugate should what? Zero out every single time, shouldn't it? Okay, so now what does this reduce to? I now have the limit as x approaches 0 of what? Plus 1 minus 1 becomes what?
0.
0. And x reduces to
1.
1. So I'm just left with 1 over the square root of x plus 1 plus 1. Yes? And now should I try direct substitution? Yes.
1.
I get 1 over 1, so I get 1. If the second direct substitution failed, that's when I would have to go what to what? A table or a graph. Yes?
Okay, so with direct substitution, so like for the square root, like for the denominator, so like 0 plus 1 is 1 in the square root, and so the square root of 1 is 1, and then on the other side,
yeah,
it's plus
this
one,
is
so we're
2.
gonna do
That's what I was gonna say.
I went with it, Maddie.
I was like, sorry guys.
That's
I
okay.
questioned myself, and then she wrote it down. I was like,
I just wrote it. A lot of times I'll just write it. So catching mistake is good because that means we're all thinking, yes? Don't just go with it, because Maddie said 1. I'm like, okay. I would have caught it in a second.
Oh, I see.
Okay, so yes, 1 plus 1 is 2.
Okay.
Yes.
Is the reason why we didn't just reduce out the
the bottom
whatever,
chunk.
the bottom chunk and the top chunk, is that because there was still an x in front of that, and that counts?
Yes. Because this is a quantity, you have to go slowly through it. You have to, it was a quantity, so I had to reduce out the x plus and minus 1 first, and then I could reduce
So
out.
you couldn't reduce out the square root of x plus 1 on top?
Oh, no, because you put that in there. We put it in. We put it in so we wouldn't get an indeterminate solution anymore. We just modified it so we would get something we could use. Yeah, we put it in, we wouldn't reduce it right back out, because we would have the original problem.
Yeah.
I do that to
Okay, now I'm
myself.
confused on why we put it in, but.
Because we put it in because I got 0 over 0, which is an indeterminate solution. You're going to start your assignment today with these problems.
Okay.
Actually, I think there may be both of them.
So if we
in
get
there.
an indeterminate solution, we have to basically change it a little bit to get it to work our way.
Right,
So like with the first one, I see that we like factored it out,
right, and then it worked.
but.
With this
so
one,
we
you can't
we couldn't do
factor
it, so we used the square.
the conjugate.
Or conjugate, yeah.
Yep. We manipulated it because this is still just 1, isn't it?
Yeah,
Because you just said, well, I could reduce it out. Well, yeah, that was the point.
yeah.
The point is to just multiply by 1.
I have a question.
Mm-hmm.
So anytime there's a square root, will we do that?
No, not anytime. Just when you get that indeterminate solution.
Okay.
Because your first thing is going to be direct substitution every time.
Yeah.
And the only time you're going to go further is if you get that indeterminate solution. If you're dividing by 0. Because if you divide by 0, that's an unreal solution. So something else is happening at that point. Okay? Okay, so this is just a picture. You don't have to write this down. We got an answer of 1/2. Yes? This was the problem we just did. Darn it. Wish it would just go there. This is the problem we just did, isn't it? Yes? Okay, so if I got there and I didn't figure it out, I could graph it. Well, look what happens at 0. It's undefined, isn't it? So that's why we were getting 0 over 0. We couldn't find an answer, could we?
Wait, what do you mean it's undefined?
It's because you'd be dividing by 0. When we did the direct substitution at 0, you got 0 over 0.
That's indeterminate.
Yeah, it's indeterminate, but this equation is also undefined. It's an indeterminate solution, like answer, but it is undefined on the problem. Okay, so then there's a hole there. So I could see, okay, well, my estimate would be 1/2. Would yours be? Yeah. Now, if I did a table, what are they both approaching? 1/2. Okay. But again, we didn't have to do these things, did we? We were able to mathematically do it. Because you guys know how long it takes to make a table, don't you? And it's a pain. You have 1 on your quiz tomorrow.
Okay, so this is your,
Make a table on our cosine.
yeah, you have to make one.
Are we able to use our calculator?
Just for that problem. Okay, special trigonometric limits. These are special. These are it. You've got to write down this whole thing. Okay? These are special. So the limit as x approaches 0 of sine of x over x is 1. The limit as x approaches 0 of sine of x over x is 1.
It will always equal 1.
Always. Because if I plug 0 in that, I get 0 over 0, yes?
Yep.
And I would have to graph it, and at 0, it is approaching 1. Like, that is what it's doing. The second is the limit as x approaches 0 of 1 minus cosine of x over x is 0. They have to look exactly the same. Got me?
Yep.
Okay.
Will any of these be on the quiz?
I don't remember if they are or not. Probably not, but I can't guarantee it. And you've already noticed, you should have already noticed when they have the trig stuff, they're usually in their own section in the textbook, correct? You've noticed that? I was looking for my book. That's what I was looking for. And everything is pretty nice on it. Why can't I find it? Because it's under the one thing that's not supposed to be.
Are we gonna do those examples?
Mm-hmm. You guys ready?
Yeah.
Okay. So, we need to think about what these are and we need to manipulate them a little bit. Because if I plug in 0 into this, I get, what is the tangent at 0?
0.
0. And then over 0. So I get an indeterminate solution, correct?
Right.
So I need to do some work with it.
Multiply the top
Okay.
by the bottom.
Well, what is tangent, first of all?
Opposite over adjacent.
Or how about functions? Let's take functions.
I think we can,
Isn't it sine over cosine?
yeah.
Yeah?
Y over x.
Yeah. Y over x, sine over cosine.
I do not remember that.
So I can write this as sine of x over x, because I had this x here, yes?
Yeah.
Times 1 over cosine of x.
Yeah. Wait, why would you put 1 over it?
Well, because tangent is sine over cosine. So, like, it's sine over cosine
So that there
over
would be-
cosine.
So
Yeah.
it's sine of
So,
x over x times cosine of x.
sine of x over x times 1 over the cosine of x. Oh, were you talking about up here? Yeah, so up here I'd multiply by the reciprocal, which is 1 over x, yes?
Yeah.
Which would give me sine of x over x cosine of x, yes? X times cosine of x,
Where did that x come from?
right here.
The bottom x?
Yeah,
I thought we moved that up to the top.
we multiplied by the reciprocal. Sine of x over cosine of x. Sine of x over,
It's really being difficult.
sine of x over cosine of x all over x. Yes?
Yeah.
So times the reciprocal, which would be 1 over x. Correct? The reciprocal of x is 1 over x.
Yeah.
So that would give me sine of x over x cosine of x. Correct? Okay. Now, using these rules, do I know what the sine of x over x is?
Yeah, it's 1.
It's 1. So why would I not separate it like this? Yes?
I was asking.
Yeah, that's right.
I just got really confused because up there, because you were making the reciprocal of the denominator into 1 over x. So if you're getting, like, if you were making that reciprocal of the denominator, would it just, like, not be the denominator anymore?
Right. It went, well, it is going to be the denominator because your numerator had a numerator and denominator. It's just going to be the denominator of the numerator. Okay, so now I know that this right here, what is that limit?
1.
1. So the limit as x approaches 0. This only works when it's approaching 0, guys. That's 1. Okay? But we also know by my rules, I can take the limit of the sine of x over x times the limit of 1 over the cosine of x, correct? Weren't those our rules at the beginning that we could separate these?
Mm-hmm.
Yes? So this is all what? What's the limit? 1. And this is x approaches 0, yes?
Yeah.
Okay, direct substitution. What's the cosine at 0?
1. I don't remember how you find it.
1. What's the x at 0?
1.
1. So that's the cosine.
Okay.
It's the this over here,
Yeah.
that point is 1, 0, and
How do I know that one is cosine?
because cosine's always x.
And sine.
And and
What if it's tangent?
it's sine over cosine, so it's y over x.
So it's like asking, like, let's say cosine pi.
Then
And
how
that's
do you
over.
know it's not on the other side?
Because it's pi, this is pi. This is 0, this is pi. And this is negative 1, 0.
Isn't that 2 pi too?
This is 2 pi.
Yeah, but how do you know, like, cosine of x there isn't negative 1 instead of 1?
Well, that's only at pi.
But it doesn't say it's at 2 pi or 0.
Yeah, it does, right here.
Because
We're approaching 0, so we do direct substitution.
yeah.
So the cosine at 0 is 1. So this is 1 over 1, which is 1, and 1 times 1 is 1. So the answer is 1.
I can help you out to understand it.
I mean, it's back to our coordinates. Knowing our coordinates and knowing that sine, remember sine is y, cosine is x, and tangent is y over x. And then knowing your points. This is 1, 0, 0, 1, negative 1, 0, and 0, negative 1.
And we know we're using that point because it's x approaching 0.
Uh-huh.
We're substituting 0 into it.
Yep. Yep, we're just doing our direct substitution after we split it up. Okay? Now, direct substitution does not work on this next one, does it?
No.
No, because you're going to get 0 over 0, and it's not going to work for us, is it? Okay, so they tell you, I was trying to think. I don't think, I'm questioning if I want to do this one, because I don't think you have to do it. What number do I stop yet? 49 through 58.
You stop us at 73.
$65 through 70. You don't have to do this one, so we're not going to do it.
Thank God. No, that's hard.
Okay. Well, it's not that bad, but it's a lot of stuff added into it. Okay, that's it.
Thank you.
Okay,